Assalamualaikum and hi. We are from Group 2 Civil Engineering Laboratory 2 Section 1. This is open-ended laboratory for H1 Streamflow measurement. Our coordinator for this lab is Dr. Zainab and our group members are Muhammad Muizuddin, Nurul Shaza Amanina, Sofia Najwa, Muhammad Idlan and Muhammad Amir Shazwan. Introduction to streamflow measurement. Streamflow can be defined as the run-off phase of the hydrologic cycle, and it is the most important basic data for hydrology studies. It can be seen in the previous process like precipitation, evaporation, and evapotranspiration. They are difficult to measure. Meanwhile, for streamflow, it is the only part of the hydrologic cycle that can be measured accurately. A stream can be described as a flow channel into which the surface runoff from a specified basin drains. In general, there is an exchange of water between the stream and the underground water. Stream flow can be measured in the unit of discharge or Q, and in this experiment, we use the formula Q equal to V times A, where V is the average velocity and A is the cross-sectional area of the stream. In order to measure the flow velocity, we can use two different methods, which are current meter method and floating object method.
There is 5 objectives in this experiment. The first one is to determine the average of water flow at cross-section. The second one is to determine the discharge of the stream by using the theory of velocity area. The third one is to improve the knowledge of the mass conservation concept in river reach. The fourth one is to determine suitable stream cross-section in river gauging, and the fifth one is to use and appreciate safety gears during river gauging.
Hi, my name is Shaza Amanina and I'm going to explain the procedure of current meter method in this experiment. The apparatus that we need in current meter method are container with water, a measuring tape, a current meter, and a measuring rod. Firstly, we need to identify two nearby cross-sections. Then, we need to measure and record the width of the river cross-section by using a measuring tape. Then, we need to divide the river into two cross-sections, which indicate what section is upstream and downstream. Next, divide the cross-section into 5 vertical subsections. After that, measure and record the flow depth of river at each subsection by using a measuring rod. Then, set the current meter to 0 reading. Measure and record the flow velocity of the river at each subsection. This step, we need to repeat it for 3 times to get the average flow velocity. Finally, we need to repeat the steps of measuring flow depth and average flow velocity for another cross-section. That's all.
Hello, my name is Muhammad Amir Shazwan bin Azim. Okay, today I'm going to conduct an experiment of floating method in stream flow measurement. The apparatus will be used are floating device, a container filled with water, measuring tape, staff gauge, and stopwatch. First, we need to mark 2 points. Point A indicates as upstream and point B is indicated as downstream. Then, the stream width measured by measuring tape and divide into 5 sections labeled with Y. Then, the stream depth for each interval S is measured by staff gauge with label Y. After that, the floating device is dropped at the upstream. When it passes the upstream, the stopwatch starts, and when it passes the downstream, stopwatch stop. Okay, then the dropping of floating device is repeated to get the average reading. Thank you.
Discussion. Based on the experiment, the percentage error that were recorded for upstream and downstream were 41% and 22% respectively. The difference between the error can be considered as high. This is due to several errors that might occur during the experiment. One of it is parallax error that occurred during the reading of the instrument, and random errors such as wind and vibration from the surrounding that may affect the results. Preventative measures that can be done were multiple readings that needed to be done to improve the accuracy. Data should be checked by multiple observers to reduce the error, and data that were affected by wind or any vibration should not be taken and need to redo. Conclusion. In conclusion, the stream discharge for upstream and downstream cross-section were determined by using velocity area concept. Total average flow water at upstream is 0.2275 meter cube per second, while 0.3192 meter cube per second on the downstream. However, several errors might cause the percentage error to increase, hence preventative steps needed to be done to minimize errors.